Hey there, everybody. Thank you so much for joining us today. We are so excited to have you for our The Heat is On webinar today. As people kind of get settled into the Zoom room, I'd love to invite you to go ahead and navigate to the bottom of your Zoom window. Go ahead and click that chat button in the bottom of the window, and let me know where in the world are you joining us from? Are you what state are you in? What are you seeing outside your window? Is it snowing? It might be snowing. Are you in Antarctica? I don't know. Let me know. We are here in Oregon. It is sunny right now, but we had that weird end of the summer rain yesterday. So we had a big rainstorm, but I'd love to hear from you. As you put your answers in the comment section, please make sure your little 2 is set to everyone. That is because Noose and I will be answering questions during today's webinar, and so we like to have everyone's chats set to everyone so that we don't look like we're talking to ourselves. So go ahead and navigate to the bottom of your Zoom window. Let us know where you're joining us from. We'd love to hear where you're joining us.
The weather station yesterday actually said raining cats and dogs.
Wow. And that's true.
I rode my bike to work yesterday, so I was like, oh. By the time I left, it was not as bad. But it came in the morning, it wasn't awful. But by the evening, I mean, it was like when someone announced it. Hi, Kimberly. When someone announced that, it was like, oh man, I looked out the window and gosh, it was pounding.
Yeah.
Yeah, yeah, I could hear
Man.
it. I could hear it on the roof too.
Oh, yeah.
So,
Man, we've got a lot of
oh,
East Coasters here
oh,
today.
nice. Well, nice evening. Welcome, nice evening for you to you all.
Yes.
Yeah,
Yeah.
it's 4 p.m. here in near Beaverton. We're just 7 miles east of Beaver or west of Beaverton.
Mhm.
Um, so, but yeah, looks like New York and New Jersey has us covered tonight.
Yep.
Yeah.
Yep.
Hey, Eric. Um, so yeah.
Awesome. All right. Well, in an effort to make the most of our time today, I will hop right into some housekeeping items. I don't know if we had the housekeeping items in our presentation news. Do you know if
I
that's
don't know what I put in there. Let me bring it. I don't. You'll have to remind me. Because I'm not terribly great with that stuff. Let's
Oh,
see.
no worries. Let's
Oh, yeah. I just have like here's us, and then at the end I have a thing that says
Perfect.
yeah. So
No worries. I can do it off the top of my head.
do it.
The housekeeping items are very minimal, my friends. First of all, I want to let you know that you will receive a recording of today's webinar. It usually takes us about 3 to 5 business days to get it edited. As soon as it's up, it'll be on our YouTube channel as well as our website. As soon as we post that to those 2 places, we will also email it to your inbox. So keep an eye on your inbox. We're going to get that recording to you as soon as possible. I also have a resources folder that I'm going to share with you as soon as I'm done talking today. You can find some experiments, today's presentation, and a certificate of attendance in there. So keep an eye in the chat for that. And the second piece of housekeeping work we're doing today, I just wanted to let you know that Noose and I will have an eye on the chat during today's webinar. So if you have any questions, please put it in there. Noose will answer your questions as he kind of gets to them. But if I see something that must be answered right away, I'll kind of pop in and interrupt him and ask him. So please feel free to drop your questions in the chat, and we are just excited to go over this with you all. So take it away, News. Thanks, everybody.
Yeah, looking forward to it. So, my name is Nüsret Hisim. Yeah, let me bring the next slide up here. And I'm a chemistry specialist here at Vernier. I taught chemistry and physics in Maryland for 34 years. And Colleen wasn't feeling well yesterday, and she said, "Hey, Nus, any chance or you could cover for me?" And so, and I believe it or not, back in the 90s, or not the 90s, I apologize, it was 2012. I took a meteorology class that dealt with the topic we're going to talk about tonight. So I had to go back and look up my notes from 12 years ago. So hopefully I get it right, but don't hesitate to hop in there and say, no, News, that's not true. Okay. That's totally okay. What we're going to do is we're going to talk about this concept of albedo, and how that affects the climate in the world, and what's going on, particularly like to focus on ice, but there's lots of other applications and stuff. So please jump in if you have anything to say about it. Colleen is a biology environmental science teacher. We are both education technology specialists here at Vernier, and we've been using this stuff for a really long time. I've known David Vernier for over 40 years, so I've been using his stuff for a long time in my classroom. So as far as hooking up the technology, I'm good. As far as, do I have the concepts right? Check me on that, especially on something I don't teach very much or at all, actually. And so albedo is related to the way that energy is reflected off the surface of the earth. And it can be light energy and it can also be heat energy. And so what we're going to do is we're going to use the Vernier sensors to try to get a little model of what this looks like in reality. Albedo technically is a fraction of the light that actually reflects off the surface. So, but a lot of times people like to talk about it as a percentage of reflected light. And so that's easy because it's a fraction. So multiply by 100 and now you have a percent. So we'll do a little bit of that. This is actually one of the images that I found from my class that I took, back in the, early 2000s and before, what the ice cover looked like in the Arctic, and then what it's looking like now. This, like I said, 2012 is when I took the class. Um, but it's, I don't know. You can tell me if it's still like this or if it's worse. My guess is it's worse. And so what is going on here? Well, it's kind of a vicious cycle, right? You've got global, you've got the atmosphere containing more carbon dioxide holding more heat, so it's causing the ice to melt. The ice normally reflects a lot of this energy, but if it melts, then what we're ending up with something that tends to absorb energy better and has a worse albedo. So that's what we're going to sort of explore here in just a minute. That's going to be the experiment that we're going to look at. This is kind of a summary, and by the way, you'll get access to this slide deck. So if you want it, you can take it and do what you want with it. But this is kind of a summary of what's going on here. We're going to be using a Go Direct light and color sensor. We're going to be using a Go Direct surface temperature probe. We're going to be using an incandescent light source, and we need to talk about that carefully because we've had teachers call in and say, experiment's not working, and then they're using LED light sources. And then I'm to just because we're inside here, we're going to use construction paper and we're going to look at different colors. Okay. So that's the plan. Nothing says you can't go outside. I mean, take your students outside, after you maybe try this experiment with your students, you might say, okay, let's go out and see what asphalt's like, or wait, what the grass is like, or something like that. So that's a chance. Well, and I think kids like going outside. I'm pretty sure about that. I know when I was teaching, any excuse to go hang around outside. I used to do reactions on a picnic bench right behind my classroom sometimes, and oh, Mr. Hism, do we have to work? But anyway, so let's do an experiment. Let me bring up the camera and graphical analysis. This is our free app. And for this experiment, the free version will work fine. You don't really need the pro version. We do have a pro option, but it's not required. Definitely not for this experiment. And so over here, I've got the equipment. I left the bulbs out just to emphasize. You want to be careful and get an incandescent bulb, one that has a filament. So this one, I don't know if that was probably not a good planning on my part. Let me see if I get a darker surface behind it, whether you can see it, that there's a filament in there. You don't want a LED bulb. This is a style LED bulb. For this experiment, you could do the reflection part, but you couldn't do the heat part of it with this bulb. So this is also a possible incandescent bulb. They're getting harder and harder to find. and it won't work. This will not work with a compact fluorescent. So, so you want to get. I have an incandescent bulb um, in this little gooseneck lamp here. So, and then for this experiment, I'm going to use aluminum foil is going to be my base. So this is going to be kind of like, the ice surface. And then I've got all these different colors we can compare. And we're going to go a little further with this sensor because you can do that. So let me show you what I'm talking about. These sensors can be connected either Bluetooth or by USB. They all come with a USB cable that you can use to connect them to a device that has a USB port. So, a computer or a Chromebook. But they can also be connected by Bluetooth to any device that has modern Bluetooth. So that could be a Chromebook, computer, it could be an iPad, it could be your phone. What I'm going to do is I'm going to connect them by Bluetooth. So I'm going to turn them on. There's a little power button on each, and probably see lights flashing now that I've got them on. And yeah, and so I'm going to click on sensor data collection, and hopefully they're going to show up here. Brand new computer, so we've only used it a few times. But then this one right here, ST, that's the surface temperature probe. We find the surface temperature probe in this one is a little bit easier to control where you put it. LC, the light and color sensor, so I'll connect to that. Some of these probes actually can do more than one thing. Any probe that has a little arrow right here, a little caret thing, if I tap on that, it shows me what the probe can do. So this light and color sensor right here, it can actually measure the amount of intensity of light that comes into the sensor. It can also split that out into parts of the EM spectrum. So I'm going to turn these channels on. So if we have time at the end, we can kind of explore that. Our main interest is going to be the light intensity, but I'm going to, like I said, I want to capture this data. So if we have time, we'll see how the clock goes. Then we'll do that. The other thing I want to do is if you go to that folder that Dylan shared for you in the chat, we have a copy of this experiment. Colleen wrote a climate and meteorology lab manual, and this is experiment number 2, I believe, in that lab manual. And each run should take about 10 minutes to get really good data. We're not doing that because we only have another half hour left here. So I'm going to go into graphical analysis, and I'm going to change the time it takes. Instead of having this thing go for 10 minutes, I'm going to have it go for 1 minute. And I'm going to change the rate it collects data to something slower. I don't need 20 samples a second. So in the actual experiment, it has you do, I think, 1 sample every 10 seconds or something like that. I'm going to make it something a little more, so we can see something happening here. Because it's about as exciting to watch as paint dry if we just let the thing go for 10 minutes. I'm also going to turn off one of these graphs. This top graph is temperature. We want to look at that. The middle graph is illuminance, which is the light coming into the sensor. And then this bottom one is telling me is breaking the light down. And right now I'm going to turn that bottom one off. So you can choose the view. You can have up to 3 graphs. I'm going to leave 2 on. So we have temperature and illuminance. And also there's little meters down here at the bottom. I'm going to make those a little bigger. So, we have a little bit better view of what's going on. So we're pretty close. Let's get things arranged over here on the table. I'm going to take the surface temperature probe, and I'm going to tape it to the table. The actual detecting element is right on the very end, a little thermistor that's right on the end. I'm going to put it right below the sensing element on the light and color sensor, but I'm going to leave the actual sensor on the surface temperature probe exposed. So we're not insulating it or anything like that. And then I want to get the light pretty close. I think the experiment says 10 centimeters or something. So I want it a little closer tonight, just so that we can see a little more dramatic change. So let's try just the aluminum foil. This will represent the maximum amount of illuminance and temperature change, I assume, or definitely the maximum amount of albedo. So I'm going to start collecting data. I'm watching the graph to see a point or two, and then I'm going to turn the light on, and we'll let this thing go. Now, for this experiment, I've got this external light. I'm going to align it a little bit more towards the sensor, and then I won't move it after that for the other lights surfaces. Um, you can see where I screwed around with it. And so this for this one, we want to also look at the effect of heat on the surface. And so an incandescent bulb is recommended for use. But there is a light, actually a little flashlight built into the light and color sensor. So if you were doing this and you only cared about the reflectance, you didn't care about the temperature or measuring the temperature, you can turn the light on in the sensor and just use that as your light source. And it works really, really well. I'm going to turn this off so we can get some cooling. And you can see it will stop at the end of whatever um, the time that you said, the duration that you set up the experiment. One thing that's going to happen, we're going to do a bunch of paper here. We're going to get a bunch of runs. And so it'd be nice to keep track of like which run is which. Okay. So if I tap on the y-axis label here, is one way to do it. There's a little pencil for right next to data set one, and we can just write aluminum in there so that, we can keep track of that. You could do this later, but it's a lot easier to remember stuff if we do it right now. Temperature doesn't look bad. I'm going to click on the graph and find that initial temperature, 22.4. You notice that it's warmed up ever so slightly. And so I've got a little fan here. Let's see if we can kind of cool it off a little bit so it's closer to the temperature that we started at before. So there's this little USB fan that I've got right here. And I think that's pretty close. So let's go to the other extreme. Let's try black paper. Okay. Theoretically, the least albedo, right? And so I'm going to start collecting data, and I'm gonna wait for a couple data points, and then I'll turn the heat on. I was talking to Dylan before we started, and I don't know how many of you folks have seen the old Beverly Hills Cop movie, but the title of this webinar is "The Heat Is On." And if you remember Glenn Fry from back in the day, there's a song from Beverly Hills Cop is like "The Heat Is On." So the temperature sensor should be under the sheet of aluminum. Yeah, the idea is like the surface is absorbing heat supposedly, and you can see the dark the black paper appears to be absorbing more. We can turn on the aluminum temperature and compare them, and you can see that the black paper is definitely warming up more. And if you let this thing run for the requisite 10 minutes that the lab calls for, you'll see a lot larger change in temperature. You can also do things that are kind of amusing, like this is black paper. Wouldn't it be nice if that line looked black? I can tap on the axis and I can change the color. Let's see, temperature for run two. Let me rename it so I don't forget. Black paper. And I can also recolor it. So I can click here where you have this doodad, and I can pick something that's close to black. I'm very bad with art, but there you go. So there's that one. You can even turn on a legend, and that way you can keep track of what's going on, for each one. The other nice thing about the software is you can have your students make predictions. So you've done a run or two, and you can say, okay, now if we switch this to white paper, what do you predict the temperature change will be? Or, you look down here and here's the reflected light around 850 to 850 lux. We'll deal with that in a minute. But what if I use white paper? So you might have your students go on there, and before they do a run, click on the little graph on the bottom and choose the option for add a prediction. My students hated this. All our software has this capability, and my students absolutely hated it. Mr. Hism, if we get it wrong, are we going to lose points? I would follow with, scientists get it wrong 99% of the time. That's the nature of science. So, you will lose credit if I don't see it on your graph, but you can have your students do this. If you have a touch screen, it's really nice, So once you have it, you can save it, and then you can come back later and look at it and see, you know, now, did I talk long enough? I did. Look, the temperature's down to 23.6, so we're ready. Let me go ahead and collect a couple of data points, and then we'll turn on the light. And I'll get rid of this thing here just because it's, temporarily, well, we'll turn some stuff back on. Can you have more than one run showing at the same time? Sure. You can go on there and you can turn on any number of runs. So, I mean, there's the aluminum there. This thing's in the way now. There's the white paper. It's hard to draw white, you won't see anything. One thing you can do when it's done, I'll show you a way to kind of make it look white. But you can, graphical analysis automatically stores runs. And so once you start collecting data, you don't have to remember. Back in the old days, our software would warn you that, oh, you had data already. Do you want me to store it? Graphical analysis doesn't even warn you. It just does it. If you don't like it, you notice that there's a little trash can. If you don't like it, you can delete a data set. So it's kind of a neat way to do things. And so this is almost done. I want to show you how to make, how do I draw white? Colleen showed me this in a data set that she shared. If I go into, I'm sorry, not here. If I go into the graph options, that's not right. No, I'm wrong. This is what happens when you don't teach this enough. It's let's go down here and let's see, where's the white? It's down here. I haven't renamed it yet. I better do that. Let's call that, white paper. And this is an option I don't use very much, and that's why, it's something that I'm not as familiar with. If I click on the color, I can also click on the symbols. If I use like an open symbol, kind of, sort of, right? Now you might say, well, gee, News, you did that, nothing showing on the screen. If I have to turn on the option to show the points. So here's the option to show the points. Now you can see that, yeah, kind of, sort of. You're not going to fool anybody. All right, let's see. Oh, I forgot to take the paper off and it's still warm. Let me turn my fan on here.
And a quick question in the chat.
Yeah, what's up?
Um, so we're wondering if the temperature sensor should be under the sheet of aluminum or under the paper.
It should be under everything. So notice that it's sitting right here on the table. And every time I put a piece of paper on, oh, here's a green one, it'll be under that. So it should be, I like the idea of keeping all the variables constant except one, which is going to be the color of the paper. And so what you want to do is tape that down, don't move anything, and then the temperature sensor should be under the paper. So the thought here is, let me start collecting data, well, because we're going to run out of time if I don't. So hit collect here and then turn it on. The thought here is the paper represents the surface of the earth. And so how do different color materials absorb light or absorb energy? So in this case, the heat, or reflect the light. And so the object is the reflected light is coming from, is being measured by the light sensor, but the absorbed energy, the heat, is being picked up by the temperature probe. So if you're doing this outside and you want to do the soil or something like that, it's going to be a little tricky. I mean, you'll have to do a little thinking about, how do you, maybe you put something to cast a shadow on a part of the ground outside. And then what you do is let that sit for a while. And then what you do is bury your sensor, maybe not completely, but you know what I mean. You just kind of let it, let the sensor go into the ground so that it's a little cooler, and then take the shade away, right? It's like an umbrella or something like that. Wouldn't it be nice if that line was green? Let's make that line green. All right, that's one that I can do very easily. And this is the green paper. So kind of an easy one. Now with the if you're doing this the way Colleen wrote the experiment, every run would be 10 minutes. You'll have to kind of fiddle with that in terms of, what's the best for your, time in your classroom and stuff. So just turn the fan on here and let's see if we can get that back down into the 23s. Got two more colors here. All right. So I've got, oops, dropped my fan. Oh, and I did bump the light. Sorry. I didn't ruin the experiment, but it would be ideal if I hadn't touched the light. All right, let's put the red in there and collect. Wait a minute, collect, get a couple of baseline points and then turn the light on, right? So very, very common with students is, they want to turn the light on and hit the button, and then maybe they don't hit the button right or something. Get a couple of baseline points in there so you can do initial and final, which I did make a spreadsheet that you're welcome to use or not use. But we'll look at the experiment here in a minute, the actual file that Colleen shared, and you'll see that there's an option. Well, there's a question where the students actually calculate the value for the albedo. And it's one of those things where it depends on the level of your students as to whether you would, provide this sheet for them or you would have them go through. Aren't there reflectance or matte also involved in the absorbance of heat, thus affecting your? Absolutely. Is the surface glossy or is it matte? Or, help me out, artsy fartsy people. I don't know all these, but yeah, that will definitely make a difference. There's no doubt. And so that might be an experiment, right? It might be, compare glossy to flat. I guess flat the right term. I think that's the right term. But yes, it will definitely make a difference. And have your students predict which one of those will have a better reflection, which one of those will have a a larger albedo. So I think that's a really good question and probably a real nice researchable. Whoops, let me cool that off. A real nice researchable question, right? If you're looking into doing something, it's a little bit on the inquiry side of things. You might actually, and by the way, I don't know if you can see it, but there's the fan I'm using to cool things off. When you're doing this for 10 minutes, something like this might be handy. This is just an El Cheapo little USB fan, so I don't have to put batteries in it. Okay, so last one, blue. Now, does that represent the surface of the ocean? Well, let's think about that. I'm going to start collecting data here and then we'll talk about it. So the vicious cycle with albedo is that as the ice melts, the surface of the ocean is darker. And since the surface of the ocean is darker, it's going to not reflect as much light and it's going to absorb more heat energy. So this whole concept of, the change in albedo is almost a circular issue because as the light, if the earth stays warm, ice has a harder time to form, and the ice is what's reflecting a lot of the light and a little bit of the heat, but definitely a lot of the light. And it can't do that if it's not there. So now, is the ocean blue? I mean, it looks blue, and it's certainly we're going to look at these values down here in a bit. And so it's definitely absorbing more light than say the the ice would be. But what a great opportunity to talk about what absorbing and transmitting means, right? I mean, this is, students may have an image of this and they may not. They might be confused by why, what do you mean it's transmitting, right? So let me turn some blue on here. That's not blue. That's bluer. Okay, there we go. So we've got all the data collected. I like this data, so I'm going to go ahead and save it. So in graphical analysis, you'll have a file menu. And so I'm going to go ahead and save this one. I'm just going to call it albedo for now. I'll change it later, but I don't want to lose it. So what's the analysis look like? Well, we don't need the camera anymore. So let me bring the spreadsheet up that I made for us. And so we can use that to do the analysis. This data at the top here is from the sample data that I took yesterday. And so I made a copy of it just so that it would be easy for me tonight. But the stuff that's kind of orangey, that's where you want to put your data. So what you're going to do in graphical analysis, I'm going to change to one graph and turn all this other stuff off so it's just looks better on the screen. So I'm going to change from two graphs to one and just have temperature for now. And we got to do both. I'm gonna leave it the way it was because we got to do both. Let me get rid of these meters. That'll give us a little more real estate here. There we go. So aluminum. Let's go find aluminum. So we see why I had to rename. Turn that on. Let's turn the other one off just because I don't want to get confused. I'm going to turn off the prediction too, so it's easier. So one thing you might have your students do is just find the initial temperature. And so click on the graph and it's 22.4, and then click on the graph at the end, it's 23.3, and then just go in there, the initial temperature 22.4, the final temperature 20, my brain power, 23.3. And they have to calculate delta T. Now, it's up to you. Like I said, if you want to use the spreadsheet, by all means. But your call. Now, there is a kind of a, let's say, a more elegant way to do things, and I'll do it with the luminance. So let me turn this thing onto for aluminum. No, that's not it. That's aluminum's for aluminum. And let me turn off the blue paper. So here is the aluminum. Now you remember I was kind of goofy and I was fiddling with it. Let's look at this last bit right here. So I'm just going to highlight that bit and notice that it pops up a little contextual menu of things I can do with the graph. And I'm going to do view statistics. And it's going to give me a mean value, 52, 48, 239. And I can put that in my spreadsheet, 52, 48. Was it 52 or 53? My old man brain. 50, 52, 48, 239. 52, 48. 0.239. Now, I did set the spreadsheet to round some of the values, so it's not a ridiculous number of significant figures. But you'll notice that 85% for the aluminum, that kind of is relatable to what was on my at the beginning of the presentation when it was talking about there. 85% of the light is reflected by the ice, 15% is absorbed. So that's not horrible, I mean, in terms of, real data, I guess. Let's do another one, and I think you guys will get the point. So I switched this over to white. Where's white? So I'll turn off the aluminum, turn on the white temperature because the top graph. And so I can do the same thing that I did with the aluminums. It's kind of, you decide with your students what you want them to do. But if you're going to use the spreadsheet, then you do have to know the initial 23.6 and the final 25.6, 23.6, and 25.6. But you can do the statistics too. So it's your call. In the experiment, this is the table from the experiment, so that's why I thought we would use that one. But what was this, white paper? So let's go and pick up the aluminums for the white paper. So you're going to have to manipulate your data a little bit here, showing me the statistics for this range I selected, but that was for that goofy aluminum that I did. Let me do the whole thing here. I'm trying to avoid this little bit down here where I turned the light on for a second or two. And so the mean value, 3644,876. 3644,876. So notice that the white paper does absorb some of the light, and you'll notice that even the temperature goes up a little bit for the white paper. And then you can go through and look at all the other colors and compare them. How does that compare to? Yeah, that's not bad. This is the data. The data at the top is the data I took yesterday, and it's actually not too horrible. Well, it was one of those things. Like, I apologize, but I haven't taught this, and so it's like, gee, I better make sure that I know what I'm doing. 22.8 and 25.5. So 22.8 and short-term memory, 25.5. So we can look at the difference between white and black, the paper, and then let's go down here and turn the black on. So the black illuminance. Oh, I lost my analysis. Let me do that real quick. I'm clicking and dragging to get this area highlighted, and the mean 851.827. So 851.827. So what that means is with the black paper, light is not being reflected as much. And so the change in temperature, of course, is really high, or I don't know about really high, but it's high. And so that blue ocean being darker, it's going to absorb more energy and it's going to warm up and it's going to cause more and more ice to melt. Yeah, we took a Disney cruise a few years ago and we went up towards Alaska, and they actually take you to a glacier where you can see the ice calving off the side of the glacier. I want to show you one more thing. And is there anything that I exported data? What am I seeing here? Are there reflectance or may? Okay, we answered that. Can the data be exported directly? Yeah, oh, absolutely. Let me show you that. So let's make this bigger so I can show you. I want to show you a couple things, but let's look at that. When you want to create a report, let's say the students need to create a report. You might have the students that you can retitle the graph and all that, but I'm running short on time. Let me turn all of the data on. And I'm just turning on all the temperature data. And this, your call as to whether you have them all on at the same time or not. But I want you to see the worst case scenario. And if I turn on the legend, and that way I can tell, what's what. Now with this setup, it's kind of ugly. So what you might do is just have them do it in separate graphs, so it's not quite so ugly. So something to that effect. And my students would have to put a title on the graph. It's in the graph options menu here. You can say, illuminance. I'll say reflectance versus time for like different sheets of different surfaces. But you will notice that under the file menu, there's no print option. You can only export things. And one thing you can do is that didn't come out well. Let's try changing the graph shape here. We're talking to the software guys about maybe moving this because that's really not great. Another option would be to take a screenshot. Then you wouldn't have this thing going on. But this down here, this PNG option, that's a standard file format. And in fact, if you notice, there's a copy icon here. And so this will paste into anything. Word, Docs, Google Sheets, Google Slides, it'll go into anything. Question was, can I export to Excel? You can export the data as a CSV and then open it in either Excel or Sheets. Graphical analysis can also read CSV files. So if you have data in that format, you could bring it into graphical analysis. The Pro version also gives you the option to create a PDF. I don't know that I would pay for the Pro version just for that option, but some people prefer that over the PNG file. So that's how you might create a report from graphical analysis. With this, the way that was looking, personally, I would probably just take a screenshot. I think that would look a little bit better. I wanted you to see the last option, because we're running short on time, is I wanted you to look at the output from, actually, let me go back to one graph. But what we're going to do is I want to look at those colors. As a chemistry teacher, chemistry physics teacher, I would really like to know, what does each surface do with the different parts of the spectrum? So this sensor can read red, green, and blue. So let's look at aluminum foil. What does the reflectance of red, green, and blue look like from the aluminum foil? And you can see it's reflecting a lot of red and it's reflecting less green. Well, how does that compare to, say, black? So I can turn the black one on, and you can see that a lot more of these are absorbed. And notice how the red and the blue have switched places. right? With the black paper, it's absorbing more of the blue end of the spectrum and reflecting, pardon me, absorbing more of the red end of the spectrum and reflecting more of the blue end of the spectrum. With black paper, you might not expect that. You might expect it to be absorbing all the colors, and it does to some extent, certainly more than the aluminum, but not not maybe what you expect. You could let's go to the extremes of paper. Let's turn off the aluminum and let's see if the white and black follow kind of the similar pattern. So when your eyes see, I used to point to my eyes and say, when these detectors pick up light, they see 400 to 700 nanometers, right? They see the visible spectrum. Notice that the blue and the white reflect, pardon me, the black and the white paper reflect a lot of the blue. And I'd have to turn this on. It'd probably better to put it in two graphs to figure out which one. Let me turn off one of the reds. We'll turn this red off. Okay, so that one is the black paper. So the black paper reflects less red than the white paper. Almost expected, right? I mean, that would be, kind of the expected thing between, well, is that true for the other colors? Let's turn off the green. Look at how much green is reflected by black paper. I'm just turning the green on and off for the black paper. And you would expect the same sort of thing, right? There's the blue end of the spectrum, and the black is still absorbing more than the white paper, but it's also reflecting a fair amount. So it's kind of neat that you can also break apart the visible spectrum and just look at the individual parts. We are running short of time. I wanted to share one more thing with you. Where did my presentation run off to? Let me see if I can dig it up here. Don't think, oh, you know what? It's sitting right there in front of my face, right there. Um, One thing well, here's the book that Colleen wrote, and this is the activity. So this is the actual book. So if you're interested in this book, when you buy books from Vernier, you buy one copy, and that's a site license for your school. So you don't buy it per student, just one. We charge $5 to print it out for you if you want. If you don't want the printed out version, you can save $5. So the experiment that we just did from that book is this one, and you get it in PDF and Word. So you can, if it's a Word file, you can change it. There's the little calculation that the spreadsheet is doing. So just be aware of that. All of our lab manuals are the same way. You just buy one copy and it's a site license. Let me see what else. Was there anything else? So some tips, and these are things I think I mentioned, at least some of them. Surface temperature works. The old temperature probe will also work. The you need you need a incandescent light bulb. Those are going to be the best. You don't want an LED. That's just not going to put up for this one where you're measuring heat. If you just want to look at the light reflected, you could use an LED. That would work fine. You could even use the light that's built into the sensor, right? The sensor, if you push the power button while it's on, a little light comes on. See the light? And so you could use that. It's not super bright, so you probably want to lower the sensor and have it closer to the paper, but that will work. If albedo is like a little overkill for your group, just look at reflection and absorbance. There's an experiment from our earth science book that's very, very similar, and it doesn't use that term. So if that term is pushing the limit for some of your students, don't use it. Right? You can do a similar experiment at maybe a little bit more understandable level for maybe younger students or something like that. Earth science, that book, a lot of middle schools use it, so it may be an option. Last thing I want to mention with the very short amount of time left is we're here for you. We are teachers. You can call us, you can write to us. For this particular experiment, something like biology at Vernier.com. I'm in the chemistry group. So if you have a chemistry question, chemistry at Vernier.com. We have physics at Vernier.com, engineering at Vernier.com. You can also go to our website and fill out a form. And you can just say, hey, I'm having trouble with the thing. And, just fill that form out and it'll come to us and we can help you out. So, Dylan, did you have any last minute thing you need to say?
No, nothing crazy for me. I'm just grateful to you all for joining us, and we're excited to get your feedback and see if you try this out in your class. All right. Have a great rest of your Thursday, everybody.
All right, folks. Good night.